Okay, so good evening, everyone. So last week we began our discussion on locus of a point. So I'll quickly review and then we'll start with problems for today. So locus of a point, it's a path or curve traced by a moving point which satisfies some given conditions. So some given mathematical conditions a point satisfies, and satisfying those conditions it traces a path that is called as a locus. An equation of the locus is uh, we call it as equation to the locus. Just a second. Yeah. Now, equation to the locus is the algebraic relation of the locus of the point which satisfies the given condition. So the given mathematical condition, if we apply and get an equation, that is the equation to the locus. So we did this to find the equation of the locus of a point. First step is to assume the coordinates of the point to be some arbitrary h comma k. Now write the conditions involving p h comma k. Eliminate any unnecessary variables, if any, and replace h by x and k by y. The relation in terms of x and y is the equation to the locus of p. So we did problems like this. Find the equation to the locus of a point which is equidistant from -1 comma -1 and 4 comma 2. So point P is equidistant from A and B. We applied the conditions and then we squared and applied the distance formula and simplified the equations, and we got this result. So this is actually the perpendicular bisector. That's what we discussed. Then a condition is directly given, so we just apply the condition and find the locus. Then we find the equation of a locus whose distance from the origin is 4 times its y coordinate. So distance from the origin is 4 times the y coordinate. So we apply and got this, and then we did this problem. The ends of the hypotenuse of a right angle triangle are 0, 6 and 6, 0. Find the equation to the locus of the third vertex. So third vertex will be the vertex of the right angle. All right. So now we applied the Pythagoras theorem and we got the relationship. So we did 4 problems. We'll do more problems on this. They are important problems on locus. We'll just view that. So 5th question. I have shared with you an assignment sheet. Let me just take problems from that. Just give me a moment. I'll share that. Yeah. See, I've shared this. I've shared this assignment with you on Moodle platform, so you can observe this assignment. of which I'll do a few problems. The remaining you should try. You should be able to do it. Okay. So let's do. Let's do. Let me think. Which is. Let us do a problem. Let's do the fifth one. The coordinates of 3 points O, A, and B are 0, 0, 0, 4, 6, 0 respectively. A point moves so that the area of POA is always twice the area of POB. Find the equation to the both parts of the locus. Okay, this is a question we'll do. Answer is also here, but let's do this. Now, coordinates of 3 points O, A, B. So it is on these coordinates. This is X, this is Y. So this is the origin. This is 0, 4 will be here. A is 0, 4 in this case. O, A, B 0, 0, 0, 4 and 6, 0 respectively. B is 6, 0. A is 0, 4. So 3 points are given. Now P is a moving point such that now P is a point such that area of triangle POA is twice the area of triangle POB. So now P is some point H comma K. So we say let P be equal to H comma K. Now area of triangle AOB is how much? AOP, sorry, POA, area of triangle POA, which is same as OAP. Doesn't make a difference. OAP, it is half modulus of, start with 0, 0. It is easy because you have to find the area of triangle. So x1, y1, then x2, y2, which is 0, 4, and h, k, 0, 0. So you get half times, just do the cross multiplication, 0 minus 0, 0 minus 4h, 0 minus 0. So you get minus 4h. Which is 2h. Now what is area of triangle POB? Again half, 0, 0, 6, 0, h, k, and 0, 0. Again apply the cross multiplication rule. this apply the formula to find the area, you get 0 minus 0 plus 6k minus 0, 0 minus 0. So you get 6k, which is 3k. Now what is given? Given is area of triangle POA is 2 times area of triangle POB. So given condition is this is the condition. So we get 2h. Now h and k, by the way, h and k can be in any of the quadrants. It need not be the first quadrant only. So h and k can be positive or negative, and areas being positive, we have to maintain our modulus sign. Now 2h is equal to 2 times 3k. So 2 and 2 cancel. Now you have mod h is equal to 3 mod k. Now you remove the signs of the modulus. Okay, this each one can either be plus or minus, plus or minus. So combination will lead us to h is equal to plus or minus 3k. Therefore, now we replace h by x and k by y. Therefore, locus of P is x equal to plus or minus 3y. X equal to plus or minus 3y. This is the equation to the locus. Please take down. Is it clear? Very simple application. Done? Can I proceed further? I have an important problem which is not reflected in this assignment. I'll do that. The next problem, question 6. చూపించు ఎక్కడ తీసుకున్నా. The ends of a rod of length L moves on two perpendicular lines. Find the locus of a point on the rod which divides it in the ratio 1:2. Read the question very carefully. Take down the question, read the question carefully. We'll discuss now. Have you taken down? Kindly respond, at least in the chat.
Yes, sir.
Okay. Are you able to see the chat? No, right? No, on the screen. If I put the chat on the screen, are you able? Is it blocking?
No, sir.
Okay. 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 All right. Because all right. Now see this. Now let the rod is of length L and it moves on two perpendicular lines. So assume the perpendicular lines to be the x-axis, x and y-axis. Now locus of the point on the rod which divides it in the ratio 1:2. So let the rod be, the ends of the rod move on perpendicular lines. Now let this be the point. Now it says 1:2. Okay. Let us take 1:2 always from the x-axis, unless or otherwise stated. 1:2. Okay. Now we have to apply the conditions. Now this point can be some x1 comma this particular point, this particular end. Let's say this is A, this is end B. This one will be of the form, say, x1 comma 0. This one will be of the form 0 comma y1, isn't it? X1 and y1 are unknown to us, but we can find out how, because ph comma k divides AB in the ratio 1:2. So so first step is let P be equal to h comma k. Now P h comma k divides the join of A x1 comma 0 and B 0 comma y1 in the ratio 1:2. Therefore, by section formula, we get h comma k is equal to 1 times x2, m x2, so 1 times 0 plus n x1, 2 times x1 by 1 plus 2 Then m y1 1 into, sorry, m y2 is y1 here, m y2 plus n y1, so you get 2 into 0, the formula, by 1 plus 2. So we get this as 2x1 by 3 and y1 by 3. So which gives us x1 is 3 by 2. Equate h is equal to 2 x1 by 3. So x1 will be 3 by 2 h, and k is equal to y1 by 3. Y1 is equal to 3k. Just hold on, some internet connection problem is there. Some technician has come. Just hold on for 2. Yeah, sorry for the break. So y1 is this. Therefore we have a is what, 3 by 2 h comma 0, and b is 0 comma 3k. Now what is given? Look here, the ends of the rod of length L is given. So what is length L? AB is equal to L. So AB is given as L. Therefore AB square will be equal to L square. So you apply this now. AB square, this is x1 minus x2 whole square, so 3h by 2 minus 0 the whole square, plus 0 minus 3k the whole square is equal to L square. So we get 9 h square by 4 plus 9k square is equal to L square. So therefore locus 9 can be brought this side. Therefore locus of p h comma k is, replace h by x and k by y, you get x square by 4 plus y square is equal to L square by 9. All right. So this will be like this. Go through this problem. This is an important, very typical problem. Very important and a typical problem. This one. What did we do? First, we marked this point P as h comma k. Then we assumed the points on the x-axis and y-axis appropriately. Y coordinate will be 0 here and x coordinate will be 0 for B. So we assume that, and then we applied the section formula. When we applied the section formula, h comma k and on AB, we get a relation. From that, we could write x1 in terms of h and y1 in terms of k. Then what did we do? Applied this condition that length AB is equal to L. So with practice, you will get these locus problems. It will improve your thinking if you apply locus problems. By the end of straight lines chapter, I have something like 40 locus problems exclusively based on the entire coordinate systems and straight lines. So I'll give you that assignment at the end. But this locus problems will really help you in thinking and building your algebraic skills. So if you are done, if you have copied, I will go forward with the next problem.
Yes.
Done? I'll move forward. So this was sixth. Now, seventh problem. This again there in the assignment that I'll give you, but this is a very interesting problem. I want you to try this. Two rods, either number 7981. Two rods of length A and B slide along I'm turning off my video because there is some technical work going on here. I'll just turn off my video. Yeah, two rods of lengths A and B slide along x-axis and y-axis. They slide along x-axis and y-axis. Doesn't mean that they uh, they slide. I will explain how they slide. After that, you do this problem such that their ends are concyclic. Find the locus of the center of the circle. What do you mean by two rods slide along x-axis and y-axis? First of all, I'll draw a circle. There's a circle. Now, there's a circle. The two rods, say one in red, this is the first rod it slides along the x-axis, and the second rod slides along the y-axis. Okay, now ends of the rod, let's say, are, you know, AB and CD. Now length of AB is small a and length of CD is small b. Okay, AB is small a, CD is b. What is asked from us? We are asked to find the locus of the center of the circle h comma k. Now please think of how you will apply this result. You have to get a relationship of h and k in terms of a and b. Nothing else is given. In the whole problem, you observe what is given: a and b. That's all. So your relationship of h and k must be in terms of a and b. Take down this figure, think of it for a few minutes. Any idea? Anybody got? Can you tell me? How will you approach this problem? And all the concepts that you need to solve this problem is already there. You know it. It is not that you don't know. If you are able to think, propose the answer. If you are not able to think, at least write no sir in the chat so that I know I will respond to it. Or if you need some more time to think, I'll give you another 2 minutes. You just tell me the approach. How about others? Someone has responded. How about others? Are you able to respond? Okay. Now I'll explain very simple geometric properties. This AB, because the four ends are concyclic, they are lying on the circle. Now P is the center of the circle. Now AB becomes the chord of the circle. CD is also the chord of the circle. Correct? So if we drop a perpendicular onto the chord, if we drop a perpendicular onto the chord, this perpendicular will bisect AB. This is the geometrical property from your high school. This perpendicular from the center to any chord bisects the chord. It will bisect at the midpoint. All right. Similarly, I drop a perpendicular from the center onto CD midpoint. It will hit the midpoint. Now, the radius of the circle is common, right? So, this is the radius of the circle. PC is the radius of the circle. PA is the radius of the circle. Correct? These two will be equal. Now, the perpendicular from the center to the chord, it is at 90 degrees. Now, what is this length to the midpoint? Let us call this point as M, this point as N. So, what is AM? AM will be A by 2. And what is CN? This point CN is B by 2. And now you have solved the problem. What is this length? PM. PM length is K, because see the coordinates. See this coordinate. This length is K. It is distance from the x-axis. And then this PN is H. This is H. This is K. So here from the figure, AB is equal to A, CD is equal to B. Let PH comma K be the center of the circle. Then let PH comma K be the center of the circle. Then PM is perpendicular from P onto AB. Huh? PN is perpendicular from P onto CD. Okay. So now, so this gives therefore AM is equal to A by 2, CN is equal to B by 2, and PM is equal to K, PN is equal to H. Got it? Now look at the figure. From triangle, see this is, I'll apply Pythagoras theorem for this and Pythagorean theorem for this. So in triangle PAM, we get R square is your hypotenuse is equal to A by 2 whole square plus k square. Just see this, what I did, I applied ap square is equal to am square plus pm square. Similarly, in triangle PCD, PCN, r square will be b by 2 whole square plus h square. What did I do? PC square or CP square is equal to CN square plus NP square or PN square. This is what I did. So in these two equations, this is equation 1, this is equation 2. R is unknown, radius will keep changing. But these two conditions will always be equal because R is equal. So from 1 and 2, R square will be equal to a square by 4 plus k square is equal to b square by 4 plus h square. So this will give you h square minus k square. H square minus k square. H square minus k square on one side will be equal to a square minus b square by 4. Therefore, locus is 4 times x square minus y square is equal to a square minus b square. Please copy. Please copy this down. If you have copied, I will have to disconnect for 5 minutes because there's some internet connection has to be done, and I'll join back. So please wait. I have to tell you about how to use the Moodle account. Right? You copy this. Just